Hi, so I'm going to talk about conditional inference tree in today's session. So what is conditional inference tree? How to implement it using R programming. So I'll be taking a couple of examples. So before we take example, we need to know what is conditional inference tree. So conditional tree inference trees are also known as CIT in the short form. So these are the different kind of decision tree. So here you need to make the comparison of decision tree and conditional inference tree. The difference is the conditional inference trees are constructed based on recursive partitioning. The nodes are partitioned recursively by checking the correlations, and these trees avoids biasing and also avoids vulnerability, means the errors are reduced um, when you compare with the decision tree. And one of the important point to be noted is conditional inference trees uses significance test, whereas decision trees uses information gain, right? Whereas the conditional inference trees are based on the significance test, where there is a p value, the probability value. In other terms, we say permutation test, and based on the p value, you can select a particular path. So I'll be showing you how the tree is constructed. So significance test plays an important role for conditional inference tree, and this algorithm is not good for data with missing values for learning. So you should remove missing values. That is the point to be noted. So what are the algorithmic steps? So here we have three steps. The step one is test the global null hypothesis. You test the global null hypothesis. Null hypothesis means there is initial assumption. Understand, there is an initial assumption, so that assumption has to be tested and it has to be proved. For example, if I say today the rain will come, then in order to prove my assumption, so the test should be performed. Understand, you have to conclude. Whenever you conclude something, you need to prove it. So that is called as hypothesis testing. So there is an initial hypothesis, we say null hypothesis, between the random input and the response variable, nothing but target variable. And then p test is calculated. So based on the p test, you can choose either left path or right path. The node is splitted. So perform binary split on the selected input variable, and step 1, step 3 both are recursively performed, right? These step 1 and step 2 are recursively performed. In R programming, so we no need to do coding from scratch or from the beginning. So we have a function that is C-tree, and this C-tree function is provided to us by the package that is partykit. So you need to first install the package partykit. So once you install, then you can avail conditional inference tree. Okay, so here this is the question. You can consider this. This is an important question which can also be asked in the interviews. So conditional inference trees, how they differ from the decision tree. The important thing is based on the significance test. So conditional inference trees uses the significance test, whereas decision trees uses the information gain or some other parameters like threshold. So Gini index can be used in the traditional decision tree, or information gain can be used, whereas in conditional inference tree you are using um, no significance test. Now let's take an example. So far we have understood. So conditional inference tree is quite different than the decision tree. Conditional inference trees are constructed based on the permutation test, we say significance test. So I'm going to take an example, the first example. So here I'll take the data set, ozone data set, which is a part of the library partykit. So if you do not have this package, you need to install. So the syntax is, let me just go through, um, let me open up my RStudio. So I'll explain this programmatically. So first you need to install the package. If you do not have, you can install. You can check whether the package exists or not, or by clicking on the package tab you can type party kit. If you are now working for the first time, so this package is not available, you need to install it. So I have this library, so no need to do the installation. But if you do not have, this is the process. So this is installation, then we need to load the library. So loading the library means the package is attached to the current script file, right? So whenever I execute this, then the package is loaded. So you can here you see we do not have the check mark before running this library of power ticket. Once you have run this statement, then the check mark there is a check mark, that means the library has been loaded. Okay, so here we are going to use the data set, that is the air quality. So to load the data, you can use data of air quality. Normally if you run the method data without any parameters, then you can see the list of the data sets which are part of R. So whenever R is installed, you can have some default data sets. So these are the default databases. Air passengers, like carbon dioxide, right? Cheek weight is there. There are many other many data sets. So one of the important data sets are the data set is US arrest, and also you have the popular one, that is iris data set is also there. So just have a look, right? Just have a look by just clicking the function, by running the function data in the bracket nothing, means you're not specifying the specific package. Then you'll be having a list of the packages available in a separate tab. Okay, so I'm just loading air quality data. So when you run this statement, the data set is loaded. So here in the values you have air quality, but there are no values, no records. So head of air quality of 3 means displaying the first 3 rows. Okay, you are displaying the, I think the previous statement is not completed, so we're getting error. Yeah, done. Let me do this again. So data of air quality, let me run that first. Next, head of air quality n equals to 3 means you want to display first 3 rows. So now the data frame has been created, and this data frame has 153 observations and 6 variables, right? So if you want to see the complete data set, you can just click on this name air quality, and this shows you the data set. So ozone, solar, wind, temp, month, day, and if you want to take help on this particular data set, so you can also search out like air quality. Yep, it's there. So this is no daily air quality measurements in Newark, and it has been developed. That means the data set is availed in 1973, and these are the columns. There are 6 variables, means 6 columns. Ozone means numeric ozone value, solar, wind, temperature, numeric temperature in Fahrenheit, and the month. So there are the values for month or numeric 1 to 12, and the day, so numeric day of the months, which is taking the values 1 to 31. So for more information, just go through this. And now what we shall do is, so the data set is loaded. I'm just displaying the dimensions. So dim is the predefined method which gives the number of rows and columns. So here in the console you can see the number of rows 153 and number of columns are 6. And after that, so we want to have a regression model. So because ozone is a numeric, so we are first considering the regression problem, and we would like to build a model. So air is equals to subsetting the data. As here we are just filtering the data, not to have the missing values. So that's why negation of is any of ozone means only no consider the rows which are having the values, which are having the data. And then now we are calling the predefined method CIT of, and this is the equation ozone is equals to tilde operator dot, means ozone is depending on all other variables of the data set. So data is air means data frame name, right? So here you have subsetted, and then the conditional tree is built. So with this the conditional tree is built, right? So built is tree is built. Next we want to print the model. So print of the model. So there is a quality tree. So this shows how the tree is constructed. Here you can see the what was the formula of the model and how the tree is constructed. You can see in the steps. You can see the steps like 1, 2, 3, 4, 5, 6. So once the left tree is constructed, left subtree is constructed, then the right tree. So you can see the numbers. 1 means the node number, like 2. So the final nodes you can see here. We can also see this with the graph decision tree, conditional inference tree graph. So in the tree we have the number of inner nodes are 4 and terminal nodes means the last nodes, nothing but leaves. So we have 5. So this is the description on the model. And next we are plotting the conditional inference tree by using the simple function plot, and this is the tree plotted. So first the temperature is considered variable. So based on the temperature value you can go to the left path or right path. So here if the and also the probability value is 0 point less than p less than 0.001. If it is true, then if the temperature is less than or equals to 82, then you choose this path, else you choose this path. And then we check wind. So node 2, this is node 2, this is then 3, then 4, 5, 6. So these are the nodes in the left subtree, right? And what about the probability value, whether it's increasing or decreasing? So here it's 0.01, then 0.02, right? It's decreasing. Got it? Increasing. So and look at the output. This is the terminal node or leaf node. So what is node 1? Node 1. So we have node 1, node 2 at the top, right? 1, 2, and this is the fourth. And in the output you can have a box plot. So box plot shows importantly 5 things. Okay. So what are those? The minimum value, the lower horizontal line representing the minimum value, then 25 percentile quartile data, then 50 percentile, next is 75 percentile, next is 100, means maximum. And you can see node 5 is giving the minimum ozone value. Got it? Node 5 is giving the minimum ozone value when you compare with other parameters. So this is conditional inference tree, and it's not exactly similar to the decision tree. So that is different. And here you have the box plot for each node. So that is a conditional inference tree, and you can also save this. You can also save your tree with this name conditional regression.png, and it's a PNG. So you're creating a PNG file, and with this name the file is created in the working directory, and then you can save the file. Say device name dot off. Done. So this is example 1. Next we'll take one more example. The next is the famous one. So you might be already knowing about this data set, which is iris data set. So iris data means it's a flower data, so which has 5 columns. So we are just loading the data, and the target variable is species, nothing but flower type. There are 3 types of flowers: setosa, versicolor, virginica, and depending on all the equation you can check. So import in the library, and then building a tree here, and this is the equation. Species is depending on sepal length, width, petal length. That's all. Okay, petal length. There is no sepal length. Sepal length is there. Petal width is not there, and data used is iris. So the tree is constructed. Then you can print the decision tree. So three inner nodes and 4 terminal nodes, and then saving this in the JPG format. Okay, saving this in the JPG format, and finally plotting. So this is the conditional inference tree. Got it. So you can see this is not refreshed, so we just need to refresh. Clear this output screen. Again run this command. It's not coming, so device dot off. Now load it. Yeah, we got it. So this is the conditional inference tree, and based on the petal length, and if value is less than or equals to 1.9, you go to the node 2, else you go to the node 3 by checking this value is greater than 1.9 or not. And over here in node 3, if the probability value is less than 0.001, and we check for threshold, whether it's less than or equals to 4.7 or not. If so, it goes this path. And you can see here in node 2, what is the class? What is the class? It's a classification problem. So we took the classification problem. So what is the class over here? So it's directly we can say it's setosa. What about here? Versicolor, little bit Virginica is also there, but maximum is versicolor, so we consider versicolor as a output. What about here? Number of nodes are 13, n equals to 3, 13, and then the maximum over here is Virginica, then versicolor. Here Virginica is maximum. So this is how the conditional inference trees are constructed. So that's it in this video. So I hope you guys have understood what is conditional inference tree and how to implement it using R programming. So do subscribe our channel so that you'll be getting the relevant videos on data science and artificial intelligence. And those who have already subscribed, do watch the channel continuously so that you can get all the concepts.